Okay, folks, talking about similar polygons and similarity today. I'm not going to worry about the warm-up. I'll begin class. Okay. We've talked about the definition for similar before. This just means that it's two figures that have the same shape and size. Oh, my bad. Same size. Nope, sorry. Same shape, but different sizes. There we go. That would be the definition for congruent. So, a couple things, right? The same shape, when it breaks down to it, this just means that the angle measurements are the same, or corresponding angle measurements are the same. That's a better way to say it. Corresponding angle measurements. Oh no. Oh no. Are the same. But the side lengths, they're in proportion. So corresponding side lengths are in proportion, or are proportional. Corresponding side lengths are proportional. So we'll kind of just do a rough thing right here. Right, if I say that this is 90, this is 90, this is, let's say, 30, so that would be 60, and that's 30. Sorry, I'm writing really super small here. Right? Those angle measurements are the same, right? And let's say if this is 2, ooh, actually, it's a little bit more realistic here. If this is 5, this is 3, this is 4, and let's say this is 9, 15, and 12. The idea is that it's got the same scale factor, right? The 3 times 3 is 9, 5 times 3 is 15, 4 times 3 is 12. That's what it means when we say that corresponding side lengths are proportional. Basically, it's the same scale factor that you multiply the original by to get to the image, the pre-image to the image. And if this was A, B, C, this would be A prime, B prime, C prime. We would say that triangle ABC is similar to triangle A prime, B prime, C prime. This little symbol just means is similar to. Cool. So which student is correct and why? We've got Priya. She says that these polygons are similar because their side lengths are all the same. And Clara says these polygons are not similar because the angles are different. Well, Claire is right. Even though the side lengths are the same, right? Which would kind of imply that they're congruent, right? But you can be similar and congruent because your side lengths, if you're multiplying, if you're, sorry, this is a little complicated. If your scale factor is 1, right, then they're congruent, but they can also be similar, right? But since the angle measurements are different, it does not hit both of those requirements for being similar. So Claire is correct because I'm actually going to, I think, change the measurements on here. I'll put that 6, 6, 6, and 6. That's better. I'm going to change that because now, like, different sizes, right? Drawings are not to scale, obviously. Claire is correct because angle measurements are different for corresponding angles. Measurements are different for corresponding angles. So yeah, you basically need these angles to be the same, right? Because that way all squares are similar to each other, basically. But this is a rhombus, so it's a different shape. Which student is correct and why? Jada says these rectangles are similar because all the side lengths differ by 2. And Lynn says these rectangles are similar. I can dilate AD and BC using a scale factor of 2, and AB and CD using a scale factor of 1.5 to make the rectangles congruent. Then I can use a translation to line up the rectangles. So Lynn is basically saying you can dilate it and then move it to prove that they're similar. And Jada says they're similar because the side lengths differ by 2, right? 4 plus 2 is 6, 2 plus 2 is 4, 4 plus 2 is 6, 2 plus 2 is 4. That might seem logically like it works. However, when you are dilating shapes, you're not adding to the sides, you are multiplying by the scale factor, right? So if I get 2 times 2 is 4 to get here to match like dA to HE, same thing for CB and GF. When I take 4 and I multiply it by 2, I should actually expect to get 8 rather than 6, right? And Lynn is saying that she's talking about scale factor, which is good, but she's saying that, 4 times 1.5 is 6 and 2.2 is 4. I mean, that is correct. However, it needs to be the same scale factor. That's what keeps the shapes being, or the side lengths being proportional when you're multiplying by the same scale factor. So which student is correct and why? I would say neither is correct. Because, well, 2 reasons, right? So Jada is incorrect because you don't add to the sides, you multiply by the scale factor. And then that actually leads into the second student, who is Lynn, and she says the scale factor has to be the same for all sides. So yeah, neither of them is correct. It has to be the same for all sides. Okay. Number 3, are these triangles similar to each other? Explain your reasoning. Oh man, I thought I had changed this. Oh no, I changed them on the exit ticket. Okay. So the idea here is that we're going to look at the side lengths here compared to this one, and if I consider this the pre-image, then this the image, I would multiply each side by 1/2. 7 times 1/2 is 3.5. 7 times 1/2 is 3.5. 8 times 1/2 is 4. You could reverse it as well and just multiply by 2 and you get it. And you can see that the sides are in proportion. And if the sides are in proportion to each other, it's kind of going to force the angles to be in proportion. So it's a yes, these sides are proportional to each other. Each corresponding side. Another way to say that is you are multiplying by the same scale factor, or you are using the same scale factor. And because the sides are the same in proportion, that's going to force the angles to be in the same proportion, right? So the angle measurements are equal, are congruent, let's say for that, are congruent to each other, right? So they are similar, so yeah. Are these triangles similar to each other? Explain your reasoning. Well, I've got this is 50, this is 60, this is 50, and this is 60. So we're kind of missing this angle, and we're also missing the side lengths. But what we can do is we can add 50 plus 60. We get to 110. Oops, 110. Then we're going to take that 110 and subtract it from 180. And we end up getting 70. So that missing angle here is 70 degrees. We do the same thing here, and we get 70 degrees here. And we have the same, angles are all the same. So corresponding, yes, they are. I should have said yes, these are similar. They are similar because the corresponding angle measurements are congruent. Okay, and now just like in the previous one when we were looking at the sides, right? And if you can prove that the sides are proportional, that's going to force the angles to be the same measurement, right? Just like this, if you had, just like the previous one, if you have the same angle measurements or the corresponding angle measurements, like this matches to this, this one matches to this one, right? And then, this one matches to this one. If you have the same measurements for your corresponding angles, that will force these sides to be in proportion, right? Yeah, so basically it's, 2 to 6 is, the scale factor would be 3 if we were enlarging it. So anyway, there we go.